Hi guys, today we'll be seeing a DP problem called coin change. It is a medium level problem and it is quite intuitive, so it's easy to understand. I'll first explain the question. So you're given an integer array coins representing coins of different denominations, and you have an integer amount representing the total amount of money. So you have to find the minimum number of possible coins that you can find to make up this amount. So I'll explain the question with an example. So for example, if we have the coins 1, 2, and 5 of denomination, assume 20 rupees, 30 rupees, 1 rupee coin like that. We have three coins 1, 2, and 5, and the total amount that we want to achieve is 11. But we have to achieve this amount in the minimum possible number of coins. So that is the question, and that is why it's dynamic programming. For example, this 11 can be achieved as 1 plus 1 plus 1, so on 11 times, or 2 plus 2 plus 2, so on 10 times plus 1. But that doesn't give the minimum number of coins. So the minimum number of coins that can be used is 5 plus 5 plus 1. So this is how this dynamic programming is found based on subsets. So for the amount 11, you first split it into amounts from 0 to 11. So your goal over here would be to find the minimum number of coins for each subset, and then finally find the minimum number of coins for 11. So for 1, 2, 3, 4, so on. So first you find the minimum number of coins needed to achieve the amount 1. Then for 0, sorry. Then for 1. Then for 2. So for the amount 2, you would need directly only one coin, this 2. Like that, so on, we keep increasing, and finally, using the previous subset, we find the most optimum solution to get the minimum number of coins for the amount 11. Suppose we have coins of a denomination, but your amount is much greater than the denomination and it's not possible. You have to output minus 1. Suppose the amount is less than your denomination, you output 0 because it's not possible. So I'll now give a more detailed explanation.
So now I'll explain a simpler way to understand this program based on dynamic programming. So these are the denominations that we have 1, 2 and 5. So your first step is to create a vector of size 0 to the amount plus 1. So you have totally 12 elements in this array. Why? Because you start with a DP of 0. Because what if your amount is 0? You need to find an answer, right? So you have a total number of elements of 11 plus 1, that is 12, because here your amount is 11. So these are your denominations. So your first step is to initialize dp, that is your dp vector with all values int max minus 1. So let me just assume int max is infinity minus 1. Why? Because you initialize each element's value to the maximum value and then find the minimum number of possible denominations. So that's why we initialize each value to infinity minus 1. The minus 1 because you don't want any value error. It can exceed the limitations. So that's why you keep a minus 1. So you initialize everything to infinity. That is int max minus 1. So I'm just representing it as infinity. Then what you do is you initialize dp of 0 equal to 0. That's what I've done here. So because your first for 0 amount your denomination is 0, it's not possible, so your amount is 0, so you start with dp of 0. Then what you do is you go to the next let it be I. The I is equal to 0 to 11, so you go to the next value of I, 1. Now you have to iterate through your coins array and find out what is the minimum number of coins that can be possible from this array to get 1. What is the answer? It is either the minimum of infinity or 1 plus the amount taken from 0 to 1. That is, it can either be infinity or from 0 to 1, how many coins can be possible with your denominations 1? And how many coins required for representing 0? 0. So it is 1 plus 0 or infinity's minimum value. Why? Because we are finding the minimum number of denominations that they are asking. So here dp of 1 is equal to 1. Now for dp of 2. One important step that I forgot to mention, you have to check if your I value is greater than or equal to your denomination value. Only if it is greater than or equal to your value, you can even continue this process. So let me go to the next step. For I is equal to 2. Now you check the minimum number of denominations that is taken to represent this number, that is 1, plus 1 will be your minimum number of coins needed for 2. So for 1, what is the number of here? It is 1. So it is either 1 plus dp of 2 minus 1, that is 1 plus dp of 1, that is equal to 2 comma infinity. Its minimum value, you get 2. But is this the minimum number of coins that are required for representing this? No. So what you do? You go to the next coin. You now check if now dp of the current value minus your denomination value plus 1 and your infinity values minimum value is what? So what you get here? 1 plus dp of 0, that is equal to 1 of 0, 1 comma 0, minimum value 1. So dp of 2 is actually equal to 1. So you not only iterate through the amount, you also iterate through different coins. So first you check for 1, then you check for 2, then you check for 5. You keep on doing the same for 11 for the previous subsets and you finally get an optimized value. Now I'll show you the code.
So now I'll explain the code. So let's see what happens here. So first, like I mentioned, you create a vector dp with the number of elements equal to your amount plus 1 and each element initialized to the value int max minus 1. So max minus 1 because you don't want to have a value exceeded error. So 0 till 11, these are your indexes, and then you initialize everything to infinity. Then what you do is you initialize your first element to 0. So this one becomes 0. Why? Because initially if your amount is 0, the number of output is also 0. Now you iterate from this is your I and this is your dp's value. So you iterate from 0 to 11 included because 11 is your amount. So you have to include your amount over here. Then what you do is you iterate through your denomination of your coins. So from 1 to 5, you have to iterate. So from I equal to 1 till I equal to amount, and j equal to 0 till j is less than equal to the coin size, you start iterating. Now you have an if condition. Here, you only have to find the dp's value if your current index value is greater than the denomination of the coin. Why? These index values are just your amount split into its previous values, right? So you get the amount 11 by adding the sum of 9 plus 10 plus 8, so on. So if your amount itself is less than your denomination, you can't get an output, right? So you don't consider it. Now you consider only if your amount is greater than or equal to the denomination of your coins. Now going to this statement. So your dp of I, this value is the minimum of two values, either the existing value or the new value, which is I minus coins of j. What does this mean? Your amount minus the denominations dp value will be the previous dp's value. That is, suppose you're taking 5. So dp of 5 minus, assume the denomination 1, that is 4. So if you use the denomination 1, then to achieve 5 from the amount 4, you will need 1 plus the number of coins that is needed to achieve the amount 4. Suppose let's take dp of 5 minus 2. Suppose denominator coins of j is 2. What is this equal to? dp of 3. This means from dp of 3, you add one more denomination, that is the value 2, then you will get 5. This is the denomination, this is the dp. And what is this? This is the number of coins required to achieve 3. So, what is the total number of coins that you require to achieve DP of 5? The number of coins that you achieved over here, that is DP of 3 plus 1. That is the one coin. That is a new denomination that you're taking. Either 1 or 2 or 5. So, there is a 1 plus DP of 1 minus coins of j. And you take the minimum because the question is asking you to find the fewest number of coins. So, you keep doing this from 0 to your amounts plus 1. And you iterate through your coins also, and you finish updating each DP value. Finally, if your DP value is less than infinity, you return that DP value. Mostly it will be less than infinity, so you just return it. Or else, if it's not at all possible, you return -1. That's all.